Well, good morning, seventh grade. It is Tuesday, April 14th, and we are going to go ahead with lesson 99, the Pythagorean Theorem. Pythagoras was a Greek philosopher and a mathematician who lived 500 years before the birth of Jesus. And this theorem is given his name, but a lot of people think that his colleagues may have come up with this theorem. But regardless of whether it was Pythagoras himself or one of his colleagues, it's a really important theorem that we're going to use in math and really in everyday life. So it's a good one to know and understand. So the first thing we want to do is to say that the Pythagorean theorem only works with right triangles, only with right triangles. So we have to have a 90-degree angle as one of our angles. Now, we got to define some things here. The two sides of the 90-degree angle we're going to call legs, okay? Like we have two legs. There are two legs in any right triangle. The third side, which is always the longest side, and it's directly across from the 90-degree angle, is called the hypotenuse. Hypotenuse. So this is what the Pythagorean theorem says. It says that you can take a leg and square it and add to it the other leg squared, and the sum of the leg squared and the leg squared will give you the hypotenuse squared, which is what I've written down here. Now, that's a lot to say, especially the word hypotenuse. So let's go back, and most people will call the two legs A and B and the hypotenuse C. And so we can say A squared, the leg A squared, plus the leg B squared will give me a sum of the hypotenuse C squared. Now, you're thinking, oh, wow. Well, how is that important? Well, let me tell you. What's great about it is if I know I have a right triangle and I know two sides of that right triangle, I can find the third side. So let's find A in this right triangle by setting up an equation using the leg squared plus the leg squared equals the hypotenuse squared. We have to be careful what our variable is. Now here, we're calling this A. Now let me just say this. You can have, this can be A, B, C, it could be X, Y, Z. You can even have C be one of your legs. Don't get hung up. It has to be an A and a B, and the hypotenuse has to be a C. That's just some general labels they've given it. But just remember, leg squared plus leg squared equals hypotenuse squared. Now, moving back. I want to find side A here. This is one of my legs. It's one of my sides of the right angle. Here's my one side of my right angle. Here's the other is 12. So remember, my two legs are squared and added together to equal the hypotenuse squared. And I have defined my hypotenuse to be the longest side and it's always across from a 90-degree angle. So 13 is my hypotenuse. So let's go ahead and set this up. I'm going to go ahead and start with my leg squared A plus my other leg squared 12, my other leg of 12 squared is going to have a sum of the hypotenuse squared. So A squared plus 12 squared equals 13 squared. Well, can I solve that equation? You betcha. I've got A squared, let's go back, plus, now 12 squared, we know what that is. 12 times 12 is 144 equals, now you may not know what 13 squared is, and we haven't been at school to do mental math much, but if we've been back for mental math, we would know by now that 13 squared is 169, but you can always multiply it out if you need to. Now, I'm going to get into the monitor glare zone, but sorry, you can still see, I think. All right, so what am I going to do to isolate A squared? The variable term, I'm going to subtract 144 from both sides, okay? The only thing different here is I'm solving for A squared, but that's okay. So A squared is equal to, well, 169 minus 144 is 25. Okay, now think about this. What number squared equals 25? Well, 5, of course, and so A equals 5, and I have solved with the Pythagorean theorem for the missing side. So A is equal to 5, and 25 plus 144 equals 169. The Pythagorean theorem works. Now let's try another one. They might ask you on the homework to find the perimeter of this triangle. And you're like, I don't know the side. It's okay. I don't know the side here, but I know the other two, and it is a right triangle, so the Pythagorean theorem will work. So let's go ahead. I'm going to step to this side now, although that's going to be hard for me. Forget that. I'm left-handed. Let's go back. Okay, so what is x? Is it a leg or is it the hypotenuse? Well, it's the hypotenuse. So I'm going to set this one up as 3 squared, the leg squared, plus the other leg squared equals x squared. Or let's simplify, 9 plus 16 equals x squared, or x squared equals, what's 16 plus 9? 25. Oh, does this look familiar? Of course it does. It's just the same side. We're going to get the same equation. X squared equals 25. My side is going to be 5, because 5 times 5 is 25. So now I know this missing side length is 5. The hypotenuse is 5. Okay. Now, can I find the perimeter? Absolutely. The perimeter is going to be the sum of the two legs, 3 plus 4, plus the hypotenuse, which is across the 90-degree angle. It is a 5. And so I get 3 plus 4 is 7. 7 plus 5 is 12. And let's just say it's inches. I forgot to write the units of measure, but we're going to go ahead and say it's inches. Can you see that? There it is. Okay, so we used the Pythagorean theorem to find the perimeter. Now we're going to use it in one more instance here. And let's do that over here. Let's decide whether a triangle is a right triangle. So right here, I didn't make that a square. I made it like a little curve with a question mark there. I don't know if that's a right angle or not. I don't know. Can I find out? Well, if it is a right angle, then the Pythagorean theorem should work. So my hypotenuse is always my longest side. So the 10 is going to be the hypotenuse, and 4 and 9 are going to be the legs. So let's see if it works. Does my leg 4 squared plus my other leg 9 squared equal 10 squared? Let's see. So 4 squared is 16, 9 squared is 81, and is that sum 100? Well, 81 and 16 gives me 97. Does 97 equal 100? It does not. The Pythagorean theorem has failed. Is this a right triangle? Do we have a right angle here? Okay. Is this a right triangle? The answer to that question is no, it is not, because the Pythagorean theorem does not hold true. Now, let's get our homework out and let's go to problem 18. We have one problem on the Pythagorean theorem, and then I'm going to do one problem from yesterday's lesson. Number 18. We have a 5, a 13, and a C. Okay, now, which one is the hypotenuse? Well, it's not C. Remember I told you a squared plus b squared equals c squared? The C may not be the hypotenuse, and it's not here, okay? The C is one of the two sides of the right angle. So C is a leg. So let's go ahead and write this equation and solve for C. So what I have here is my leg of 5 squared plus my other leg of c squared equals 13 squared. Let's go ahead and solve it. So I have 25 plus c squared equals, now 13 squared, remember from the flip side, I told you that is 169. Okay, let's isolate our variable term. To do that, it has what added to it? It's 25 plus c squared. It's the same thing as c squared plus 25. So I'm going to subtract 25 from both sides. I'm going to subtract 25 from both sides, and I have c squared equals 144. Does that sound like something you can solve? What number squared would give me 144 as a solution? Well, of course, it's 12. My c value is 12. Now let me double check and see. Do I have to have a unit of measure there? Because sometimes I missed out on that. No, there's no unit of measure on that problem. So it's simply C equals 12. Okay, now let's go ahead and go to the problem on number 21. Problem number 21, let me flip it, is from lesson 97. Is from lesson 97, which is yesterday's lesson. And it's a little bit tricky. That scale factor is a little scary. Okay, so let's first go back. This part A is from the similar triangles lesson. And so let's look at that first. And so what I have here is a bad 6. Okay. All right. So number 21 on the homework. Be doing this one with me. I want to find X. All righty. Now, I have two similar triangles. These angles are the same measure. These are the same measure. So if two are the same measure, the third one is going to have to be the same measure. And so they are the same shape, but not the same size. Okay. Now, let's find two sides that correspond to each other. And that would be 12 and 8. 12 and 8. Let's start our proportion. 12 is to 8. Now put your equal sign, okay? I've got left triangle is to right triangle as X is to 6, okay? As X is to 6. All righty, that's it. 12 is to 8 as X is to 6. I'm matching up corresponding sides. Now this is a little confusing because that's a 6 right there, but we don't need to, this is a 6 too. Don't worry about that 6, okay? We're worried about 12 is to 8 as X is to this 6. Okay, now let's go ahead and cross multiply. I have 8X equals 12 times 6. I'm going to divide both sides by 8. Let's do some canceling here. Alrighty, it doesn't matter. I'm just seeing this 6 and this 8. I'm going to divide both of those by 2, giving me a 3 and a 4. Well, 12 over 4, isn't that wonderful? Is 3 over 1, and I have 3 times 3. X is 9. Now, this one does have a unit of measure, and it is 9 inches. 9 inches. Okay, so I'm going to box that. X equals 9 inches. Now, let's move on to what I think is a little bit trickier, and that's scale factor. We want to know what is the scale factor from the smaller triangle to the large triangle, okay? So I want to know, I'm going to use my 8 and my 12. What am I going to multiply 8 by? What scale factor? And I'm going to multiply 8 by to get a corresponding side of 12. Well, I'm going to set up an equation. In other words, my small side length of 8 is multiplied by what scale factor to give me the matching side of 12 on the larger triangle. Now let's divide both sides by 8. And I'm going to reduce this 12 over 8, both divisible by 4. Divide 12 by 4 and you get 3. Divide 8 by 4 and you get 2. My scale factor, let's just stick it right here, is 3/2, which is 1.5. I noticed that, and you can put F equals to just 1.5, I don't take care. I noticed somebody told me that in the Zoom lesson, and by the way, you guys come to Zoom if you need help. So many of you are not coming, and these are hard problems, and I miss seeing you, okay? I miss seeing you. So anyway, they told me that in the My Math Assistant that they only took the decimal answer, which really isn't exactly right. But let's go decimal because we don't want to. I don't want to rock the boat here. So, but you're going to need to enter in 1.5 for your scale factor. So, in other words, 8 times 1.5 gives me 12. 6 times 1.5 gives me this length, which we found to be 9. Okay. So now this is the hardest part. The area of the larger triangle is how many times the area of the smaller one? Well, we don't have a height here to calculate the areas to compare them. And it says the hint is use the scale factor. So what we're going to do is the scale factor is 1.5. Now to compare areas, what we learned yesterday is that we take the scale factor to compare areas and we square it because area is square units. To compare volumes, we cube it. But let's compare the areas. Let's take 1.5 and multiply it by 1.5. I'm running out of room, so I'm gonna erase that squared and rewrite it as 1.5 down here, and we'll get our answer. So we're gonna square the scale factor to see how much greater the area, how many times greater the area is. So let's see, I'm getting a 75 here, I'm getting a 15 here, I'm getting a 225 with 2 decimal places. So my answer is 2 1/4, but let's go decimal. 2.25 times greater, okay? I'm just gonna put 2.25 times greater here and box the whole thing. The area of this triangle is 2 1/4 times as big as the area of this triangle, and we found it simply by squaring the scale factor, okay? So that is it, and my box is not great. Okay, so what are our omissions today? Oh, look at that, 7 omissions. Oh yeah. So we've got 3, 9, 10, 11, 14, 15, and 22 we're omitting. Also, Khan Academy is due on Friday evening at midnight. So get that Khan Academy done before Friday. It's only Tuesday, but get it done by Friday, and our omissions are 3, 9, 10, 11, 14, 15, and 22. So put an X through those on your worksheet. Don't forget, y'all are putting the answers in Math Assistant, but some of you, I'm not seeing the answers uploaded. So I'm gonna have to hunt you down and get those because I have to put them missing until I can check over your work. So please, it's a 2-step process. Math Assistant, upload to the practice problems page, okay? 2 things for every lesson. It's kind of like we grade, that's what Math Assistant does, and we turn in the homework, okay? So uploading it is turning in the homework to me, okay? And Math Assistant is grading it for you to get feedback. All right. Have a great day, and I will see you tomorrow. Or at Zoom later today. Zoom at 1 and Zoom at 2. 7A at 1, 7B at 2. All righty. Have a great afternoon. Bye-bye.